Yeah, so what is the data science process? What is KDD, knowledge discovery in data mining? I think this term is now a little bit old and obsolete. I think it's people typically use data science for that. It's the process, the non-trivial process of identifying valid, novel, potentially useful, and ultimately understandable patterns in data. You see, this definition is again as old as the Greek culture, but yeah, that's how it is. Yeah, so as old as the Greek culture, that is actually, so again, the database community, in the database community, there are a lot of Greeks actually, yeah, working in Greece, but also in the US and in Hong Kong and in Singapore. And so they are very strong national subgroup, so to say. And they actually like to say, if someone refers to something very old, one of the Greeks typically stand up and say, oh, come on, that is actually as old as the Greek culture. I like that anyway. Yeah. So what is in there? Non-trivial, okay, valid, novel, potentially useful. I think that's quite intuitive, ultimately understandable, of course, also. And once again, I would say people use data science, the term data science, instead of KDD nowadays, which is probably also fair enough. So here is the process. You probably know from KDM or from big data management or whatever. So you have multiple steps in order to get the knowledge out of your raw data. So typically the raw data is somewhere distributed maybe over different sources and systems. So first of all, you have to integrate the data and also clean the data from errors, from inconsistencies that may even arise after the integration, of course, yeah, and so on, missing values, all that stuff. Typically, you load a kind of data warehouse, data cube, multidimensional cube here, and then that is not yet that what you actually use for your fancy shit, but you still have to transform your data, maybe select attributes. We will talk about feature selection quite a bit in this lecture, actually. Maybe you want to do projections. Yeah, the projections are the feature selections. Actually, selection means you may select only those tuples that are, or data records that are somehow relevant to your application, whatever. So sampling and stuff like that. And again, transformation, you need to transform your data types, for example. You need to transform data types. You need to, I don't know, normalize the data, whatever. Yeah. So everything what you do before you really apply your fancy SHEIT. Yeah. So for example, machine learning approaches, data mining approaches, whatever. Yeah. And then you get patterns, or you try to visualize the whole thing with your, that is the typical data warehouse OLAP world, where you get all these fancy dashboards and reports for the management. There's just a visualization of this this data cube. So once again, this predictive exploratory analysis, that would be dashboards and reports for your management. Yeah, but you can also do this predictive modeling. So that would be exploratory descriptive modeling. That would be predictive modeling here, machine learning and data mining, get patterns, and then of course visualize all that stuff also, so that hopefully the user gets some idea about what is in the data and why things are happening and stuff like that. And maybe you can also do predictions, yeah, predict the customers' likes and so on and so on. Very important, the process may have a lot of back loops, so it may be that you are here, you are absolutely not satisfied what's coming out, so you get a step back, see, did you do the right thing here? Maybe you even have to go back here and say, okay, an important data source is missing, or this and this data source doesn't mean anything to my problem, so throw it out and use a different one. Yeah. So even if you are here, doesn't mean that you have to go back to this one here. Yeah, so keep that in mind, and that's why everybody's talking about agile in that context, and that is really helpful in that case. Yeah, try to be prototypic in that case. Try to be agile, even though you probably already got it. I hate buzzwords, but in that case, agile project management is absolutely helpful. Yeah? Yeah, this is not the only visualization of the data science process. There are different which are very similar, actually, very similar process models available. For example, CRISP-DM is another one that actually is more or less the same. Yeah, uses a little bit different terms, has a little bit different view, because it says before we do that we need business understanding and stuff like that. Okay, easy. So that is more the technical view of this process. CRISP-DM has a little bit of different view, but in the end it's more or less the same. Yeah? So don't get confused about that. Yeah, then the first steps here typically take more than 85%, some say even more than 90%. My personal view is, because I'm doing some consultancy, or did some consultancy in the past for companies to do that, sometimes it's even, or mostly it's even more than 95%. Yeah, those two steps here before you can even apply the whole thing, the fancy stuff. Yeah, takes 90% of your resources. Yeah, but of course are extremely important. Yeah, because this here, the task relevant data, if this is not of high quality, if this is, you see it here, if this is shit, then data mining gives you shit also, of course. Yeah, and also, of course, visualization will be shit. Yeah, so that is the famous, once and for all, shit in, shit out problem. So those steps here are extremely important, but many people consider this to be very boring. So writing some ETL scripts, meaning you have to write thousands of lines of SQL code to get the things from the source data sets, data sources into a data warehouse, and then transform and project and select and blah 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 blah. Yeah, writing parsers, writing SQL scripts can be really, really boring, because many of those things are extremely application dependent, but usually not very sophisticated. Yeah, close to being trivial. But someone has to do it. And if this someone doesn't take care too much, we have the shit in, shit out problem. Yeah? So be clear that before you can apply the fancy stuff, a lot of things have to be suffered, yeah, so to say. Yeah, typical tasks during pre-processing here, for the first step here, for cleaning and integration, you need to identify and select the data, relevant data sources. Of course, you have to integrate the data from, overcome system boundaries, different tools, different database systems, different operating systems, and so on and so on. Yeah, of course, you try to at least not decrease data quality, but in the best case, increase data quality by detecting and eliminating noise, detecting missing values, and somehow do something with it. Very often, you just delete records with missing values. Try to detect and somehow overcome inconsistencies and stuff like that. Yeah? And many, many more. Once again, very, very application specific. And then here you, in the transformation step, you typically select the useful features and objects, derive new features, do a feature transformation, maybe a discretization, maybe a normalization, maybe do dimensionality reduction and stuff like that. Yeah? And once again, very, very task specific. And you can imagine that especially here, you probably have to try out different things. Yeah, so typically data science is a process chain of several steps, and all these steps offer some kind of some degree of insecurity, of fuzziness, of potential for an optimization, of course. Yeah, so think about the whole process, and each step is so the selection, which algorithm or which method at each step is a kind of input parameter, a meta parameter, and which you try to optimize actually. So you try to find the best meta parameters for the whole process, meaning that you try to find the best possible combinations of methods in the different steps here, yeah? Which sometimes give you really, really a hard time, and you see that you go through this whole process, maybe not from the beginning, but parts of it many, many times to find out the best solution sometimes.